Okay, welcome to section 4.3, multiplying matrices. Multiplication of matrices gets its own section because it is a pretty long algorithm. It's easy to get lost in the numbers. In fact, I will probably make several mistakes, which I will either have to edit out or I'm just going to scratch out the numbers. Let me talk about some basics here. One is that the dimensions are restricted. What does that mean? Basically, remember when we did addition and subtraction of matrices? If they did not have the same exact dimensions, you couldn't add or subtract them. Well, in multiplying matrices, they don't have to be the exact dimensions, but they do have to meet certain requirements. For example, if you have a 3 by 2 matrix, it requires a 2 by something matrix to multiply with. The key in multiplying matrices is the number of columns in the first matrix must equal the number of rows in the second matrix. Okay, so in fact, this 3 is not important. Okay, the dimensions on the inside must be identical, and I'll show you some examples of that in a minute. All right. Multiplication of matrices is not commutative. And squaring of matrices, remember, squaring is multiplying something by itself, only makes sense with square matrices. Squaring of matrices only makes sense for square matrices. For square matrices. Okay. Alright, I'm going to do several examples. Bear with me. It is very easy to get lost in these problems, so I will probably make a lot of mistakes. Alright, this is example 1. You would think I would do this in advance. Alright, anyways. Here we go. So we have a 2 by 3 matrix, 2 rows by 3 columns. And this is a 3 by 1 matrix, 3 rows, 1 column. We're checking the dimensions here. The number of columns of the first matrix must equal the number of rows in the second matrix. The product matrix, the product of the two matrices, is going to be a 2 by 1 matrix. Okay, a 2 by 1. So I'm only going to have 2 rows and only 1 column. Alright, and this is how we're going to calculate it. We're going to go along the row of the first matrix and follow the column of the second matrix, multiplying and then adding the products. So we're going to say 1 times negative 4 plus negative 1 times 1 plus 0 times 6. Okay, I'm going to write it out here. It's 1 times negative 4 plus negative 1 times 1 plus 0 times 6. And that's all going to be combined together to make one element. Okay, one cell. Now the second row comes from second row times the column. So it's 2 times negative 4 plus 4 times 1 plus negative 3 times 6. Alright, I'm going to say that again. So it's 2 times negative 4 plus 4 times 1 plus negative 3 times 6. 2 times negative 4 plus 4 times 1 plus negative 3 times 6. Alright. Go ahead and let's simplify this. So that's negative 4 plus negative 1 is negative 5 plus 0 leaves negative 5. 2 times negative 4 is negative 8 plus 4 is negative 4 plus negative 18 makes negative 22. If you got lost in there, just pause the video and go back and check the numbers out. It's 2 times negative 4 plus 4 plus negative 3 times 6. Oh, I get lost in those big numbers myself. Alright, that's example 1. That's my answer. This is the product. Example 2. Well, what I'm going to do is switch the order of multiplication in example 1 to show you what I'm talking about when I said earlier that multiplication is not commutative. I think I just stole my own thunder. 1, 0. This is a 3 by 1. This is a 2 by 3. And because of our definition, that should mean this row times the first column. Well, this row only has one number in it, and this column has 2 numbers in it. So I don't have things to line up. -4 times 1 plus what times 2. So that's the problem. The size of the row has to match up with the size of the column. So that's why I can't do the multiplication. So here we say it's undefined. If you didn't understand anything I just said, the key here is I have to have matching dimensions here. The number of columns of the first matrix and the number of rows of the second matrix must be identical. If they are not identical, then we say it's undefined. The multiplication is undefined. The product is undefined. Okay? Example 3. I think I'm going to run out of space. So we switch over to another piece of paper. I am not killing trees. I am keeping lumberjacks employed. Alright. Example 3. Okay. Here we have a 3 by 2 matrix, and we have a 2 by 3 matrix. So that means my end result is going to be a 3 by 3 matrix. Right? The inside dimensions are okay. Alright, I guess I'll write it out. Well, see if you can follow along. I'm going to try to do it all in my head. Okay, this is where it gets confusing. Now, we're going to go this way on the first. We're going to go horizontally on the first matrix and vertically on the second matrix. So element 1, 1 is going to be first row times first column. Element 1, 2, right? This is 1, 1. This is 1, 2. Is going to be first row times the second column. 1, 2. Element 1, 3 is going to be first row times third column. Element 2, 1 is going to be second row times first column. Element 2, 2, second row, second column. Element 2, 3 would be second row, third column. Element 3, 1, third row, first column. Element 3, 2, third row, second column. Element 3, 3, third row, third column. Okay? And if you think about it, it makes sense with these cell addresses, right? Element 1, 1, first row, first column. Element 1, 2, first row, second column. Alright. Alright, here we go. So 1 times 0 plus 4 times 2 is 8. Next one. 1 times 1 plus 4 times 0 is 1. 1 times negative 1 is negative 1. 4 times negative 2 is negative 8. Negative 1 plus negative 8 is negative 9. Next one. 2 times 0, 5 times 2, 10. 2 times 1 plus 5 times 0, 2. 2 times negative 1 plus 5 times negative 2, negative 12. 3 times 0 plus 6 times 2 is 12. 3 times 1 plus 6 times 0 is 3. 3 times negative 1 plus 6 times negative 2, that's negative 3 plus negative 12 is negative 15. I'm going to try to clean that up a little bit, get rid of all those cell addresses to show you final answer is 8, 1, negative 9, 10, 2, negative 12, 12, 3, negative 15. Okay. And that's example 3. Moving on to example 4. Now what we're going to do with example 4 is I'm going to switch the order here. We're going to switch it around. Now notice we've got a 3 by 2 matrix and a 2 by 3 matrix, and we can actually switch it around. Okay, let's do that. So this time it's a 2 by 3 and a 3 by 2, which means we're going to get a 2 by 2 matrix. We're going to get a square matrix. Alright. So here, first row, first column is going to give us 1, 1, cell 1, 1. Then first row, second column will give us cell 1, 2. Cell 2, 1, second row, first column, cell 2, 2, second row, second column. Alright. There you go. 0 times 1 is 0. Plus 2. Plus negative 3. Giving us negative 1. 0 plus 5 plus negative 6 gives us negative 1. 2 plus 0 plus negative 6 gives us negative 4. 8 plus 0 plus negative 12 gives us negative 4. So, here, in example 4, we have the order of multiplication switch from example 3. But, even though the multiplication is defined, we have completely different answers. Okay? So, still, even if switching the order is defined, multiplication is still not commutative. That was the point of that. Multiplication is not commutative. Alright, one more example. We're going to square a matrix.